Hello everyone, this is Sidharth Sinha, roll number 20IE135, and this is the demonstration of our final DIY project for this particular week. Our group comprises of me, Sidharth Sinha, Ahana Ganguly, Kajol Sahu, and Nematullah. Realizing the need for social distancing in the pandemic, we took it upon ourselves in order to construct a simple social distancing detector from scratch using the techniques of OpenCV Python library, the YOLOv3 algorithm, as well as other libraries present in Python. It wishes to make sure that people follow the social distancing norms, which have become a very important part of our lives considering the pandemic and how it can be altered only by maintaining a certain distance unless the vaccinations are released in their full form. So as a result, we have constructed a social distancing detector which wishes to alarm people in case a certain distance has been, if they do not follow a certain distance that has been established by the social distancing norms. Let's have a look at the structure of the project. For this particular project, you can see there's a module file which consists of all the configuration files as well as the parameter files that we shall be using in our social distancing detector.py file. Then we have the YOLO file which consists of the pre-trained weights that have been established using the COCO set in the YOLOv3 algorithm. Then we have the beep.mp3 file which is there in order to tell which sound has to be played during the using the play sound library that we have made use of in this particular file. Then we have a set of 5 videos which comprises of all the data sets which comprises of all the scenarios, the practical scenarios that can be realized in real life, and we shall be implementing a social distancing detector on all 5 of them to see how effective it has been in detecting people and alarming them in case of social distancing violations. These 5 videos cover practically all scenarios that are possible and have been chosen from around the world. Now let's have a look at our social distancing detector project in practical. Firstly, I'd like to change the directory to the particular source code. Yeah, now that the directory is changed, first let's have a look at the v1.mp4 file. As you can see, this is the v1.mp4 file which has been chosen from somewhere in Europe, and we shall be seeing how well our social distancing detector works in detecting people that are violating the social distancing norms as has been established. Now let's run the social distancing detector.py file. I shall be running that using the Python 3 command and providing to it as input the v1.mp4 file. As you can see, the social distancing detector is in fact very effective in determining the number of social distancing violations that are taking place here. The social distancing violations number keeps on updating, and as per that, if it is greater than 2, then the social distancing violations alarm goes on, and we can see that we can hear a beep sound. It is very effective in detecting the number of people in terms of how it works. In fact, you could even go to the extent of saying that it is even better than normal human people would be able to, since it can also detect people at the very back of the things, where it is very hard for even a normal human to detect people and determine the distance between the two. In this particular street scenario, we can see that the social distancing violation detector is very effective and can be very useful if integrated with the right things in order to make sure that people follow the social distancing violations. Let's have a look at other street scenarios. Moving over to the second video file, let's see what it looks like. This particular file has also been chosen from somewhere in Europe. As you can see, there's immense amount of crowding in the back. Let's see how our social distancing detector works in that particular scenario. Let's run it again using the Python 3 command and provide to it as input, this time the second video. As you can see, again it is very effective in detecting the people initially at the front. However, one challenge that we still face is to make sure that these people at the back which are basically very small, and there's intense amount of crowding due to a very high density that has to be overcome somehow. This is obviously not a practical scenario, because in a normal pandemic situation where a social distancing detector has been employed, such a crowding would not take place. However, we still feel that the YOLO algorithm could work better in sense by detecting the people at the back much more effectively, so that the right number of social distancing violations can be shown at the screen. Apart from that, detecting people at the front, it has been seen to be very effective, and in fact, in general detecting of people, the YOLOv3 algorithm is very fast and efficient in detecting people, as you can already see on the screen. Now let's have a look at the third video, which is the V3 video. Let's open it. As you can see, this is an intensely crowded area from somewhere in China. Let's see how our social distancing detector works in this scenario in order to determine what further modifications that can be made, or what challenges that the YOLOv3 algorithm still faces in our particular case, in our particular implementation. Let's run it using the Python 3 command and provide to it as input the v3.mp4 file. As you can see, there's an immense amount of crowding in this particular area. Alarm has been switched off because there's an immense amount of change in social distancing violations, and therefore it has not been on for this particular scenario. However, you can see there's a huge block of people that can be seen here that has been detected as one people, and that is essentially where the problem lies. This is something that we wish to work upon, that can be taken as a practical challenge to this in cases where there is a huge density of population living in the very short area of the camera. However, this is not a practical scenario, as you can realize. That's because in a scenario like this where a social distancing detector has been employed, obviously crowding to this extent will not obviously take place, and hence in every practical scenarios where social distancing has been employed, our social distancing detector works very effectively. However, in scenarios like these, as had been told by sir, and we took it upon ourselves as a challenge in order to effectively somehow see how it is working over this particular region, and you can see the impact on the screen. It still can be made better if this block could be deconstructed into smaller people, but it stays as a challenge, and we wish to work upon it somewhere in the near future. Now let's go ahead and have a look at the fourth video, which has been taken in a busy Indian street, and see how it works. This, you can see, is a very usual morning street that can be seen anywhere in India. Now we shall be having a look at how the social distancing detector works in this particular scenario. Alright, let's run using the Python 3 command and provide to it as input the v4.mp4 file. As you can see here as well, it is very effective in determining the social distancing violations, even when it can even detect people where only the head of the person is visible, something that would be very hard even for a human at this angle to achieve. In that terms, the social distancing detector is very successful in doing so. However, one thing that remains is that there needs to be a certain mapping of distance, since you can see even these blocks coming together seem to be clashing with the scenario, and therefore that's also something that we wish to achieve using our social distancing detector in the near future. Now let's have a look at our fifth and final video that we shall be seeing for our particular project. This is an example from South America of a busy street where people are shopping. Let's have a look at how effective our social distancing detector is in this particular scenario. Let's run it using the Python 3 command again and provide to it as input the v5.mp4 file. As you can see, there's a certain limitation that we have faced in this particular project. It's that a certain amount of people crowding in a particular area leads to the detection of a huge block that we don't wish to do. As you can see that it is detecting in some cases. However, besides that, the social distancing detector again proves to be very effective in determining the social distancing violation. As you can see, even the smallest of the people which are very far from the camera can be very effectively detected. Also, with this particular video, we also wish to show you how the detector works in the case of an overhead situation. As you can see, the camera is placed in an overhead position over the entire scenario. The detection of the big block that you can see is one of the challenges that we faced, and something that the YOLO algorithm could further be worked upon. However, besides that, again, the social distancing detector proves to be immensely helpful in detecting the amount of social distancing violation and can alarm people in case they do not follow the social distancing norm, which is the very need of the hour. So this marks the end of our DIY final project. As you can see, our social distancing detector is very effective in almost all practical scenarios and realizes the importance of social distancing detector until and unless we have a fixed solution to the pandemic and the vaccines aren't rolled out in full form. Till then, the use of computer vision that we have realized, and we took it upon ourselves in order to make sure that people follow the social distancing norms via the help of the social distancing detector. We see the viability of this particular social distancing detector in several situations, and it is also very feasible because it is very cheap and does not require anything besides the source code and development. Just a CCTV camera that has been employed possibly in most areas, even of India, right? So with that, we mark the end of our DIY project. We find our project to be very insightful, and we wish to implement it as a feasible solution to social distancing, to making people follow social distancing norms in the near future. Thank you for listening.